side by n elements, it will be shifted here. Okay, and the last element will be the, so minus n plus 4 will be there because we are adding minus n to all the elements. So minus n minus plus 1 minus n plus 2, it will become minus n plus 4. Next, when you take the reflection, this will become x of n minus k, x of n minus k. So minus n will become equal to the plus n. Okay, and minus n plus 4 will become equal to the n minus 4 here. Okay, so this will become equal to the n minus 4. So we have done the same thing. Okay, so here we plotted the waveforms. H of k we have plotted. H of k, it is from 0 to the 6 here, and x of n minus k we have plotted, that is from n minus 4 up to the n, it will be there here, up to the n it will be there. So now what we need to do is we need to take the many conditions we need to take. First one is the non-overlapping condition, or based on the waveforms we are going to take the condition of the n we are going to take here. Okay, the first case we are taken is n is less than 0 we are taken, and there is no overlapping of the sequences when n is less than 0. So y of n is obviously become equal to 0 will get here. That is the first case we are taken. And the second case is when n is greater than or equal to 0 here. When n is greater than or equal to 0. So, and also in the meantime we need to take that. So since its length is lesser than the length of this one, the length of this one is lesser than the length of this one. Okay, so here you are going to take n is less than greater than or equal to 0, and n minus 4 is less than the last sequence, first sequence you are.
Sir, you're muted, sir.
Yeah, okay, someone has muted me, I guess. Okay, no problem. So up to from 0 up to the n, there is a overlapping of the waveform will be there. So I'm going to take the condition n is greater than or equal to 0, and n minus 4 is less than 0 you're going to take. It is not going to overlap with the 0. So in that case, when we take the product of this one, so from 0 to n, there is a overlapping of the sequences will take place here. So we can write k can take the value in the summation. We can replace. We can write the we can write the convolution sum. Afterwards, we can replace the value of x of n minus k with the h of k as a product here. The product is 1 into alpha to the power of k is alpha to the power of k will get here, alpha to the power of k. So the k can take the value from 0 to n here. So we have substituted and we got the result here. And n value also we have got. So that is from 0 to the 4 we got here. So because n can take the value greater than 0 and n minus 4 is less than 0, means n can take the value from 0 to the 4 it will take here, less than 4. So we got like this. So this is we applied the generalized formula, sum of finite terms formula, and we got this one here. So right. So this is a first quantity we got here. That is by applying the formula. So next is okay. So the next one is the page number 55. Okay. So after this one, we have taken the next value of the n we have taken. That is the case number 3 we have taken. Case number 3. So the case number 3 is. The case number 3 is, so we got the value of y of n. So for these cases, okay, this is the case number 2. Case number 3, what we have taken is, so this is a waveform for the x of n and n here. So we are going to take the value of n is less than the 6. We are going to take here the value of the n. This value of n is less than the 6. We are going to take here. This is the value of n is less than 6, and n minus 4 is greater than 0. We are going to take here greater than 0. So that is the next case you are going to take. N is less than 6. And n minus 4 is greater than 0, so that this waveform is going to move between the 0 to 6. It can take any value it will take here. This set of data is going to take any values. So the overlapping will be there from the overlapping will be there from the n minus 4 up to n. It will be the overlapping will be there here. N minus 4 up to n it will be there. So if I solve for this one for the different values of n, so n can take the value from 4 to 6 here. Okay, so that is the value of n it will take, and the overlapping will be there when I take the product of this into this one. The overlapping will be from n minus 4 up to the n. The product is alpha to the power of k. So that's what we have substituted in the convolution sum. K can take the value from n minus 4 up to the n. The product is alpha to the power of k into 1 here. Alpha to the power of k into 1. So since we don't have the formula similar to this one, we have the generalized formula. I'm going to substitute this one. It is equal to the. So I'm going to send n minus 4 this side here because we want 0 at this case here. So k plus n minus 4 will k minus n plus 4 will get here. I'm going to make that one is equal to some variable called L. We are going to make here L. Okay, and we are finding the value of k in terms of L here. We got this one. When I substitute the lower limit, the value of L will become 0. When you substitute the upper limit, the value of L will become equal to 4. The same thing we are reflected in the summation. The same thing we are reflected in the summation here. So this is a summation, we are reflected the same thing. So L can take the value from 0 to 4, alpha to the power of L plus n minus 4. So since n minus 4 is not a function of summation, we can take outside and we apply the sum of finite terms formula. So we got this one here. So right. So this is for the case n is less than or equal to this one, and we have summarized that one. So we got y of n is equal to alpha to the power of n minus 4 into alpha n by this one. So what we have done is we have multiplied the alpha to the power of n minus 4 with the this quantity we have multiplied here. Okay, so this one we have multiplied, and we got this is a quantity we got here, that is y of n is equal to this one. 4 is less than or equal to n is less than 6 we got here. Next case, we are going to take this is the waveform. So we have taken the two cases we have taken. Next we are going to take n is greater than 6 we are going to take here. N is greater than 6 here, and n minus 4 is less than 6 we are going to take here. So that is n is greater than 6 and n minus 4 is less than or equal to 6. So at least there will be overlapping will be there. N is moving outside the range of this one here 6, and n minus 4 is going to lie less than this one. So when you take the product is going to encounter from n minus 4 up to the 6, the n up to the 6 it is going to take place, the product will encounter here. So that is we need to take the lower limit as n minus 4 and upper limit will be this one here. So right, when we take the product it is alpha to the power of k. So I can substitute in the summation, k can take the value from n minus 4 up to the 6 here, alpha to the power of k. Here also let us do the substitution, change the limits here. So we got this one. So it is L is equal to 0 to the 10 minus n, alpha to the power of L plus n minus 4 we have got here. So we have done up to this in the last class here. So got it now? So I continue from this part. So any doubts till this point? So I'm going to read it here. So y of n is equal to the summation L is equal to 0 to the 10 minus n, alpha to the power of L into alpha to the power of n minus 4. This is not a function of summation. I'm going to split the term here. So right. Done, right? Okay, next we are going to apply the sum of finite terms formula, that is summation n is equal to 0 to n minus 1. Okay, or you can take summation n is equal to 0 to n. This is a better formula. So a to the power of n is equal to, so it will become 1 minus a to the power of n plus 1 divided by 1 minus a will get here 1 minus a. Okay, provided a should not be equal to 1. Provided a should not be equal to 1. Okay, so we are going to substitute y of n is equal to the, so alpha to the power of n minus 4 will be there, and this is 1 minus alpha to the power of 10 minus n plus 1. So this is a n here, 10 minus n plus 1. Okay, so divided by, the formula is correct now. Okay, alpha to the power of n only, right? N plus 1 or n? What is the formula? Alpha to the power of n only, no? N not or n plus 1 now. So this is n only, right? Can you get the reply? So this is n plus 1 or n? What is the formula? What is the formula for sum of n terms? Summation n is equal to 0 to n. Okay, so it is n plus 1 will get here, n plus 1. Right? My voice is audible now?
Yes, sir.
The formula is correct?
Yes, sir. N plus 1, sir.
N plus 1. Okay. So 1 minus alpha to the power of 10 minus n plus 1 divided by 1 minus alpha, provided alpha should not be equal to 1. So that is y of n is equal to, so 10 minus 10 plus 1 will become 11 will become here. So let us multiply this alpha to the power of n minus 1 here, n minus 4 to the entire terms. So alpha to the power of n minus 4 minus alpha to the power of 11 minus n is present here, plus n minus 4 divided by 1 minus alpha. So this will become alpha to the power of n minus 4 minus alpha to the power of 11 minus 4 is 7, it will become here, minus n plus n will get cancelled, divided by 1 minus alpha, provided alpha should not be equal to 1 here. So this is for the case. The case we have taken is, so n is greater than 6 and n minus 4 is less than 6 we have taken here. So that is this is for the case n is greater than 6 here, and n minus 4 is less than or equal to 6. So when you send 4 this side, it will become n is less than or equal to 10 will get here. So n can take the value 6 is less than n is less than or equal to the 10 will get here. Okay, so this is the value of y of n we got here. That is 6 is less than n is less than or equal to the 10. Let us summarize the value of y of n here. And for n is greater than that one, there is no overlapping here. N is greater than 10, there is no overlapping. Okay, or n minus 4 is greater than 6, there is no overlapping of the waveforms here. Okay, so done. Let us summarize the value. It is 0 for, so we got the values here. So it is 0 for n is less than 0. Let us summarize this one. So this is a 12 marks question, and it is equal to the 1 minus alpha to the power of n plus 1, alpha to the power of n plus 1 divided by 1 minus alpha for 0 is less than or equal to n is less than 4 here. Okay, so that is the case 2 we got here, and in the case 3 we got, so case 3 we got it is alpha to the power of n minus 4 minus alpha to the power of n divided by 1 minus alpha. So this is for 4 is less than or equal to n is less than or equal to 6 here, and for this one 6 to 10. So we have alpha to the power of n minus 4 minus alpha to the power of 7 divided by 1 minus alpha. So this is for the case 6 is less than n is less than or equal to the 10 here. Done, right? Okay, so it is done, right? You got the values. You got the values. So this is the value of the y of n we got here. So these are 12 marks question. It will be asked in the exam. Okay. Done. We'll take the next problem. So these problems at any cost you should score out of 8 marks. You should score in the convolution sum. If you have any doubts in any kind of problem, you ask me. I'm going to take all the different kinds of problems I'm going to take. Okay, so because the convolution, it's very interesting. The concept of I told here, how to get the concept, how to draw the waveforms here. Okay, so the concept is very simple, but don't miss the terms, don't miss the values. Okay. Okay, let us take this problem. Given x of n is equal to, so this is the problem number, so yes, problem number 16. Okay, so given x of n is equal to 0.5 to the power of n into u of n, and h of n is equal to 0.5 to the power of n into u of n plus 3. So I'll write here h of n is equal to, okay, so 0.5 to the power of n into u of n plus 3 minus u of n minus 4. So find y of n is equal to x of n convolution with h of n. Find y of n is equal to x of n convolution with h of n. Video clarity is there, right? Clarity is there in the video. Clarity is there in the video. Is it okay?
Yes, sir.
Okay, fine. So this is similar to the previous problem. These are also the same thing, but here it's a one is a infinite duration sequence, other is a finite duration sequence. Okay. So what I'm going to do is, so x of k, I'm going to write in place of x of n, I'm going to write x of k here. It is 0.5 to the power of n into u of n here. So since point n is equal to 0, if I substitute here, it will become 0.5 to the power of 0 is nothing but 1. For n is equal to 1, it will become 0.5. For n is equal to 2, it will become 0.5 square is nothing but 0.25 will get here. So it's an exponential decaying signal will get here, decaying signal. So let me plot that one. So this is x of k. So x of k will get here. So this is k. So at k is equal to 0, I want x of k, that's why I'm writing here k is equal to 0, k is equal to 1, it will be decaying, k is equal to 2, k is equal to 3, and so on up to the k is equal to something called infinity, it will become almost equal to 0. So this is 0.5 to the power of k, because u of n already I'm included in the time limit here. So this is x of k will get here. X of k will get. And next one is 0.5 to the power of n into u of n plus 3, u of n minus 4 here. u of n plus 3 minus u of n minus 4 means the signal is going to start from the minus 3 up to the plus 3 it will be there, and from u of n minus 4 the signal will get cancel each other here. So u of n plus 3 is nothing but from minus 3 the signal is going to start here. U of n minus 4 is nothing but from minus 4 it is going to start here, minus 4. When you take the difference of this one, sorry, plus 4 it is going to start this one. When you take the difference of this one, the signal from n is equal to 4 onwards, it will get cancel each other here, cancel each other, so that we are going to get the signal from minus 3 up to the plus 3 will get here, minus 3 up to the plus 3, and this is multiplied by 0.5 here. So let us plot the waveform for that one. So this is for the h of k. I'm going to plot here h of k. So this is k. So this is for k is equal to minus 3, minus 2, minus 1, 0, 1, 2, and 3. It will be there 1, 2 up to 3. So when I substitute n is equal to minus 3, so 0.5 to the power of minus 3 is nothing but, so it is 1 by 0.5. Minus is nothing but, so 0.5 to the power of minus 1 is nothing but, it will become 1 by 0.5. So this will become equal to 2, right? So 0.5 to the power of, so 0.5 to the power of minus 3 is nothing but, it will become 2 to the power of 3, 8 it will become here. So it will become 8 here. So for n is equal to minus 3, for n is equal to minus 2, it will become 4 here. Getting right? How the signal will get the amplitude, and this will become equal to 1, and this will become equal to something called 0.5. So like this, it will be there. So this is 1, and this is 0.5. So this is 0.25. So this is 0.125. So no need to worry about the amplitude. Just I'm plotting here, just for your understanding. I'm plotting the waveforms here. So there is no need of plotting because in the formula itself we can evaluate that one. So right, we got this waveform here. Now among this one, among these two, so let me take introduce the shift in this one here, because we can make a play with this one easily rather than this one here. Okay, so we can play easily with this one. So let me take this one. I am going to fix here. We're going to introduce the shift in this sequence here. So right, so let us take y of n is equal to, so convolution of h of n with x of n I'll take here. So h of n convolution with x of n. So y of n will become equal to the summation k is equal to minus infinity to the plus infinity. So h of k into x of n minus k, h of k into x of n minus k. Done. Done, right? Okay, fine. Now we want x of n minus k. We have x of k is there here. I want x of n plus k. So first let me plot x of n plus k. Means the signal will be shifted towards the left side by n elements here. Okay, so it will be shifted towards the left side by n elements. So just I'm going to take only just u of k. I'm going to take here. U of k I'm going to take. So just I'll take the part of okay. So let me take u of k here. So u of k plus n let me take here, because if you take 0.5 to the power of k, so you'll get confused here. So minus n minus something will get confused here. So just I'll take u of k plus n. So the signal will be shifted like this here. So it will be there up to the infinity. It will be there here. U of k plus 1. Later I'm going to include the 0.5k in the formula. We can introduce that one here. Done. Next, u of n minus k means when I take the reflection, it will become u of n minus k. So this will go to the positive side here. So this is become u of n minus k. So already we are done in the previous problem. So n can take the value like this up to the infinity. It will be there. So this is n. This is minus k. Assume this is equal to the minus infinity. So the corresponding amplitude is 1 here. So we don't know what is the value of n here. So we take the value of n based on this sequence here. Then, so we got u of n minus k, and we got h of k we got here. Now based on this one, I'm going to take the product here. I'm going to take the, we are going to take the value of n will be taken, and we are going to evaluate the sequences here. Okay, so let me write the waveforms here. Let me write the waveforms. So of these two quantities, let us write here. Okay, so I'm writing the waveform for the x of k. So this is x of k will get here. So sorry, I'm writing the waveform for the h of k. I will write here first. H of k. H of k. So this is so from minus 3, minus 2, minus 1, 0, like this. 1, 2, 3 will get here. So minus 3, minus 2, minus 1, 0, 1, 2, 3. I'm going to fix this one here. H of k. So this value is nothing but it's a 0.5 to the power of k, 0.5 to the power of k. Okay, so other one you are going to take u of n minus k will take here. So this is part of the x of n minus k I'm taking here. Okay, u of n minus k. So this is the value of n. This is the value of n here, minus k up to minus infinity. This is n here. We are going to take here. So this is u of n minus k, value 1. I'm taking the part of x of n minus k we are taking there. So done. Done, right? Now we are going to take the case 1 here. The case 1 in this case will be the value of n is less than minus 3. So there is no overlapping of the waveforms here. The value of n is less than minus 3. There is no overlapping of the waveform. So when n is equal to, so when n is less than minus 3, when n is less than minus 3, so no overlapping of the sequence. Therefore, so y of n is equal to 0 for n is less than minus 3. So getting right? Everyone getting right? If you have any doubts, you can ask me, because this is very important concepts. Easily you can score the marks here. Just you need to understand the concept, that's it here. It's not difficult, but everyone feels that convolution is very difficult. But if you plot the waveforms, if you know the conditions, easily you can do it. Any problem, you can do it easily. Done? Done?
Yes, sir.
Okay. So next, we'll take the value of n here. So since it's a finite division sequence, what I'll do is n is greater than minus 3, I'll take here, and less than plus 3, I'll take here. So n can take the value. It can move anywhere between the minus 3 to the plus 3, but less than 3, I'm going to take here. Less than 3. Okay. So less than 3, I'm going to take here. So let us take the conditions like that step by step. Let us take here. Okay. So n is less than minus 3. Next, n can move between the minus 3 to the plus 3. Any value it can move it here. Next, n can take the value greater than 3. It will take here. Like that will take. So next, case 2. Case 2. When n is greater than or equal to minus 3 and n is less than or equal to plus 3 here. Less than or equal to plus 3 also you can take, no problem. Less than or equal to plus 3. So in that case, what will happen is, so h of k waveform I am plotting here. So h of k. So this is h of k. So it will be ranging like this here. So minus 3, minus 2, minus 1, 0, 1, 2, 3. So from minus 3 to the plus 3, it is ranging 0, 1, 2, 3. So minus 1, minus 2. So right. And this one, it is going to move anywhere here. So just I'm going to move it here. So this is u of n minus k. Let me take n will be here. So something called it will be takes here like this up to the minus infinity. Let us assume that this will be go up to the minus infinity. This is 0, 1, minus 1, minus 2, minus 3, minus 4. So this is 0 something n here. I'm going to take here. So this is the k axis. Okay, this is u of n minus k. So when n can take the value between minus 3 to the plus 3, it can lie anywhere. It can lie here. Anywhere it can lie like this. Now when you take the product here, the product is going to encounter from minus 3 up to the n. It is going to take place here. Minus 3 up to the n. The product is going to encounter here. So that is minus 3. So minus 2, minus 1, 0. Okay, up to the n. It is going to take place here. So this is minus 3, minus 2, minus 1, 0. Up to the n it will take here. So this is a product of h of k into u of n minus k. It will take here. H of k into u of n minus k. So h of k is nothing but we have it's a 0.5 to the power of k. Okay, and u of k is nothing but it's a 0.5 to the power of n minus k will get here. So done. Okay, so I'm going to recall the formula. So we got the limits from where k is going to exist from minus 3 up to the n. We need to find out the limits of the k so that the value is going to be present here. So I'm going to consider the formula. So y of n is equal to summation k can take the value. Generalized formula I'm writing here. So this is h of k because we introduce the shift in the x of n minus k. Okay, so h of k is nothing but, so since k can take the value from minus 3 up to the n here, k is equal to minus 3 up to the n. Okay, so h of k value, so h of k value is it's a 0.5 here, 0.5 to the power of k. 0.5 to the power of k, and x of n minus k is nothing but we have x of n is equal to 0.5 to the power of n into u of n, and x of n minus k is nothing but, so if you have x of n minus k is nothing but it is 0.5 to the power of n minus k into u of n minus k here. U of n minus k, this is x of n minus k here. I am substituting for that one because u of n minus k we are reflected as the limits of the time duration we are reflected here. So I'm going to write, so x of n minus k is it's a 0.5 to the power of n minus k we are going to write here, 0.5 to the power of n minus k. Then now let us split the summation terms here. So this is y of n summation k can take the value from -3 up to the n. So 0.5 to the power of k, and this is 0.5 to the power of n, and 0.5 to the power of minus k here. So 0.5 to the power of minus k and plus k will get cancelled, and 0.5 to the power of n is not a function of summation. I can take outside the summation here. Okay, so you can getting right. Okay, so 0.5 to the power of n, the summation k is equal to -3 up to the n, so it is 1 will be there. 1 will be there. Done. Done, right? So we know the sum of ones here. When it is taking from 0 to n, it will be n plus 1. When it is taking from -3 to n, so it will be n plus 1 minus of -3 it will become. So n plus 3 plus 4 here. Done, right? Everyone taken this one? Everyone taken this one, no? Taken, right? This is 0.5 to the power of n.
Yes, sir.
Okay, so now I'm going to write the formula for this one, the generalized formula. So the generalized formula for this one is, so we have summation n is equal to 0 to something n of 1. So this will become n plus 1 here. So the other formula is summation n is equal to minus n naught to the n of 1. So if you're going to take here, so this is n plus 1 plus n naught will get here plus n naught. So similar way you're going to get here also. So that's why you can make the list of the formulas at the end of your notebook here. So if I forget, so you should remember and you should remind and tell me what is the value of this one. Okay, I think everyone is making the list of the formulas at the end of your notebook. Okay, so done. So this is 0.5 to the power of n. Okay, multiply by. So this is n plus 1 plus 3 will become. So this is n plus 1 plus 3. So this is become 0.5 to the power of n into n plus 4 will get n plus 4. And the value of n can take the value. N can take the value from -3 up to the 4 it will take here. Taken. So n can take the value from -3 up to the 3 it will take here. N is less than or equal to the, so that is -3 is less than or equal to n is less than or equal to the plus 3 here. So this is the value of y of n will get here. Done, everyone. So writing this limit is very important here. If you have any doubts in any problem, you can ask me. I'll explain once or twice. I'll take the different kinds of problem. Okay. Done, right?
Yes, sir.
Yeah. So now I'll take the case. So we are done this one. So you underline this one. So next one, let us take the case. N is we are taken, which is going to lie between the -3 to the +3. It is going to lie here. Now I'm going to move the n greater than the 3. I'm going to move here. So when n is greater than the 3, I'm going to take here. N is greater than the 3. So because we have the two limits left out here. Okay. So n is -3 to +3 we are taken. The next condition we're supposed to take is n is greater than the 3 we're supposed to take here. So that it is going to move outside the 3, it is going to take here. So let us take the case number 3. So case number 3, when n is greater than 3, because already equals we are taken here. So n is greater than 3, let us take here. I'm going to plot the waveform for the h of k. So this is h of k will get here. So this is k. So this is -3, -2, -1, 0, 1, 2, 3. 1, 2, 3. So next one is u of n minus k. I'll take here. So this is u of n minus k. So why we are taking, so I'm going to take the n is greater than 3. So this is some way here 3 will come. So 2 will come, 1, 0. So -1, -2, -3. Up to infinity, it will be there. So because this is the infinite duration sequence here, up to infinity, it will be there. So minus k, so -4, and so on, it will be there here. So this is u of n minus k. So this is having the value 1 here. Now, when you take the product of this one, okay, so from -3 up to the -4 up to the infinity, minus infinity, there is no signal for the h of k. And here after 3, that is 0, 1, 2, 3. So this is 0, -1, -2. Okay, so when you take the product of these two, so when the product is going to exist here, from where to where? From where to where the product is going to exist? When you take the product of these two sequences.
-3 to +3.
Yeah, very good. -3 to the +3, very good. So it is going to exist between the -3 to the +3. So 1, 2, 3, it is going to exist here. -3, -2, -1, 0, 1, 2, 3. So this is the product of h of k into u of n minus k. The product is going to exist here. Done, right? Now let us write the summation formula. So let us write the formula for the y of n. So y of n, write the formula. Write the formula. So just a minute. Okay, so the formula is summation k is equal to minus infinity to the plus infinity. Let us write the generalized formula. So it is the value of this one is, it's a 0.5 to the power of okay, so 0.5 to the power of k. This is for the h of k, and for the x of n is 0.5 to the power of n minus k into u of n minus k, u of n minus k. So it will become, the product is going to exist from -3 to the +3. It is going to exist here. I can change the limits of the summation. K is equal to -3 up to the +3. Okay, so k is equal to -3 up to the +3. The summation is, it's a 0.5 to the power of k, 0.5 to the power of k, and this is 0.5 to the power of n minus k will get here. 0.5 to the power of n minus k. Now let us split this term here. Summation k is equal to -3 to the +3. So 0.5 to the power of k. Okay, so into, so 0.5 to the power of n into 0.5 to the power of minus k. So plus k minus k will get cancelled. So resultant will be, so 0.5 to the power of n is not a function of n. So 0.5 to the power of n, summation k is equal to -3 to the +3. It is 1. So if you're going to add the 1 from -3 up to the +3, so -3, -2, -1, 0, 1, 2, 3, it will become 7 here. Or else 3 plus 1, it will become 7 also. As per this formula also, it will become 7 only. Okay, so as per this formula also, it will become 7 only. So now this will become, so 0.5 to the power of n into, so 3 plus 1 plus 3. So this will become equal to, so 0.5 to the power of n into 7. So this is for the value of n is greater than 3 here. This is the value of n is greater than 3. Then let us summarize the values here. Let us summarize the values. Okay, so we got, let us summarize the values of this one. So y of n is equal to, so when you are writing this one, when we have many ranges here, so we make y of n is going to sit at the mid of this position. For example, 3 values are there. So 1, 2 should be equal to the mid one, and third one should come here like that. So this is 0 for n is less than the -3. For n is less than -3, it is 0. So for n is -3 to the +3, it is 0.5 to the power of n into n plus 4. This is from minus 3 is less than or equal to n is less than or equal to the plus 3. Okay, so next one is, so 0.5 to the power of n into 7 into 0.5 to the power of n. So this is for n is greater than 3 here. 7 into 0.5 to the power of n. This is for n is greater than 3 here. Done. Okay. So right. Okay, so I'll take one more example problem. I'll take here. Any doubts in this one? Any doubts? Any doubts in this one? No doubts? Or doubts is there?
No, sir.
Okay.
No, sir.
Yeah. So take next problem. So this is the exam problem. Given x of n is equal to u of n minus 10 and h of n is equal to u of n minus 2 minus u of n minus 7. Find y of n is equal to x of n convolution with h of n. Got it now? Find x of n is equal to u of n minus u of n minus 10. H of n is equal to u of n minus 2. So this is n minus 2 here. Minus u of n minus 7. Find y of n is equal to x of n convolution with h of n here. So let me plot the waveforms here. First I will plot x of n, u of n minus u of n minus 10 means u of n is nothing but it is going to start from 0. U of n minus 10 is nothing but it is going to start from 10. When we take the difference of these two, so from 0 to 9 the sequence is going to exist here. So that is x of k, we can plot it here. So k, so this is x of k. So from k is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So up to 9, we have the value 1 will be there. We have the value 1 will be there up to the 9 here. And the next one is h of k. H of k is nothing but, so from n is equal to 2 up to the 7 means, so from 2 to 6 the value will be there. That is k is equal to 2. So it is 3. This is going to start from n is equal to 2 or k is equal to 2, and this is going to start from 7 here. So when you take the difference from 7 onwards, all the signal gets cancelled. So we have the signal up to the up to 1, 2, 3, 2, 3, 4, 5, 6, up to 6 we are going to get the signal. The corresponding amplitude is nothing but 1 here. You can see the notation what you are going to use here. So this is at k is equal to 2, it is going to start here. We will have see the signal like this. Okay, so now tell me which signal shall we introduce the shift here. So this is the exam question asked for 8 marks. So this is the 8 marks question here. So tell me which signal shall we introduce the shift here, x of k or h of k? Which one shall we introduce the shift here? Anyone?
X of k, sir.
X of k. Okay, so fine. Let us introduce the shift in the x of k here. So h of k we are going to keep it as a constant. So I'm going to take y of n is equal to, so h of n convolution with the x of n. So y of n is equal to summation k is equal to minus infinity up to the plus infinity. So h of k into x of n minus k. H of k into x of n minus k. We written the formula. We have h of k, let it like that only. So we want x of n minus k. So first let us plot h of n plus k here. So the signal will be shifted towards the left side by n units here, n units. So I'm going to plot for x of n plus k. So this will become minus n plus 1 up to the minus n plus 9 it will become here. So I'm going to draw it here. So minus n we are going to add here because x of n plus k is the limit. So plus n we are going to add here, minus n we are going to add here because x of k plus n. So it is nothing but x of k minus of minus n, we can assume here. Okay, that's what we know in the signal operation. So this is minus n plus 1. So plus 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is x of n plus k or k plus n here. So this is k plus n. Okay, so this is nothing but minus, okay, so minus n plus 9 will get here, minus n plus 9. This one we are adding the minus to all the terms. So this is how we are learned how the shifting of the signal can be done here, time shifting. Done, right? E doors in this one. Now let us take the reflection of this one. So this will become x of n minus k will get here. N minus k means this will go to that side. It will become plus n. So this one plus n minus 1. So like that. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will become n. So this will become n minus 9 will get here, n minus 9, because when you take the reflection, this will become plus, this will become minus here. So n minus 9. So this sequence you are going to call it as a x of n minus k, we can call here n minus k. Got it now? So this is n minus 9. This will be n here. Done. Okay, now I'm going to redraw the waveforms here. So if you want, you can redraw it here, or else we can take the sequences like this, we can take here. So let me take here like this only. The first case is n is less than 2, we can take here. N is less than 2, so there is no overlapping of the sequences here. Right? If you want, you can redraw it here, or else no problem. H of k, x of n minus k is here, not an issue. So this is 1, this is also 1 here. Okay, first case is n is less than 2, we can take here. So there is no overlapping. So you can take when n is less than 2. So no overlapping. No overlapping of the waveforms. So therefore y of n is equal to the 0 will get here. Y of n will be equal to 0. Okay, so that's the first case we can take. Then what's the second case? What is the second case? What is the second case we can take? So when you're taking the cases, you should know the length of this one. The length of this one is 1, 2, 3, 4, 5, and the length of this one is length 10 sequence will be there here. So right, what is the second case? Anybody? Can I get the answer? What will be the second case? If you are silent means that will reflect your semester end exam results will be reflected in your silence. Yeah.
N greater than or equal to 2 and
Yeah.
n less than or equal to 6.
Yeah, very good, excellent. Okay, so n is greater than or equal to 2 and less than or equal to the 6 here. So very good answer, right? Good analysis. So take the case when n is greater than or equal to 2 and less than or equal to the 6 here. So if you are silent means if you are idle means, so in the exam, okay. So when n is greater than or equal to, so when n is greater than or equal to 2 and less than or equal to 6 here, and n is less than or equal to 6 here. So I'm going to draw the waveforms here. So I'm going to draw the waveforms for this one. So this is h of k. So let me draw h of k first here. So this is h of k. So from n is equal to 2, 3, 4, 5, and 6 it will be there. So from 2, 3, 4, 5, 6, and x of n minus k. So this will be from, it is having the length, okay, so n minus up to the 10 it will be there. So it can take any value between 2 to 6 here. So let me take here somewhere else. So this is 1, 2, 3. Okay, let me take 3 samples overlap here. So 4, 5, 6, 7, 8, 9, 10. Okay, so this is n here. So the last sequence is n here, and this is n minus 9. Okay, so when you take the product of this one, so the overlapping will takes place from 2 to n. It is going to overlap here because we are taking n is greater than 2 and less than 6 here. So from 2 to n, it is getting overlapped here. The product will overlap between 2 to n here. So we are going to encounter, so 2, 3 up to the n, which is going to overlap here. So this is the k axis. So this is the product of h of k into x of n minus k. So this is 1. So from 2 to the n, it is getting overlapped here. Okay, so we can take y of n is equal to summation k can take the value from 2 to n. The product is 1. The product of this one is 1 into 1 here. So when 2 to n, if you are going to overlap this will become n plus 1 plus, sorry, minus 2 will get here, minus 2. You got now, you know the formula, right? N minus 2. So this is y of n will become, so n minus 1. So far, this is 2 is less than or equal to n is less than or equal to the 6. So this is the value you'll get here, n minus 1 will get here. Then it's visible, right? So n minus 1, so 2 to 6 will get here. Then, okay, now I'm going to take the value. So what's the next case? So case 3. So this is the case 2. So what's the case 3? What's the case 3? So n we are taken greater than 2, less than 6 here. So next, what is the value of n here? What's the value of n?
Greater than 6, sir.
Yeah, so n is greater than 6. In the meantime, n minus n is less than the 2 we can take here, less than the 2, so that it is going to overlap between these two. This is a sequence here. So this sequence is getting overlapped between these two sequences. It is getting overlapped here. So greater than 6, less than 2 here. Okay. So since this is a finite division sequence, we need to take both the cases we need to take here. Okay. So n is greater than 6 and n minus 9 is less than or equal to 2 here. N minus n is less than or equal to 2. So you can take when n is greater than 6 and n minus 2 is less than or equal to the, so sorry, this is n minus 9, right? N minus 9 is less than or equal to 2 here. So this means that minus 9, if you go this side, it will become, so this is n is less than or equal to 11 will get here. So 6 is less than n is less than or equal to the 11. So means, so we can plot the waveforms here. So this is the waveform for the, so 2, 3, 4, 5 and the corresponding values. So this is, we'll get here. So this is h of k, and I can make n is greater than the 6. Let us take here. So it will be somewhere here and somewhere here. So this is 6th one, 5th one, 4th one, 3rd, 2. Okay, and this is n, and 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 9, 10 sample. So this is n minus 9, and this is the x of n minus k. So this is 2, 3, 4, 5, 6, 7, and somewhere n will be there. I can take the value. So when it move the n between n minus 9 is less than 2 and greater than this value. So you're going to get the product here from 2 to 7, 2 to 6. The product is going to encounter here 2 to 6. So the product will be 2, 3, 4, 5 at the corresponding. The value will be equal to 1 will get here. The product is 1 here. So this is h of k into x of n minus k will get here. The product is 1, that is going to encounter from 2 to 6 here. So right. Then so here we can take y of n is equal to summation k can take the value from 2 to the, okay. So the product is 1 here. So this will be equal to the 6 plus 1 minus 2. So it will be 6 plus 1 is 7 minus 2 is 5 will get here. So y of n will be equal to 5. So from where to where? So from the value of n is 6 to the 6 is less than n is less than or equal to the 11 it will take here. 11 it will take. Then so this is the value we got here. So what are the values we got? Let us highlight these values here. Taken everyone?
Yes, sir.
Okay. So next, what shall we do? Next we can move. So n already we moved outside the 6. We have moved here. So next one is what should we do? N minus 9 can take the value between 2 to the 6 here. N minus 9 can move between the 2 to the 6. It will take the value here. So take the next case here. So I'll take some 2 minutes of time. I will take here. Is it okay? So that we can complete the problem. So there is no carrying over. Okay. So done. Shall I take 2 minutes? Shall I take 2 minutes of your time? Is it okay?
Yes, sir.
Yes, sir.
Yeah, okay, fine. So
Yes, sir.
in the case, yeah, thank you. So n minus 9 is, so n minus 9 is greater than or equal to 2 and less than 6 here. So when n minus 9 is greater than or equal to 2 and n minus 9 is less than or equal to the highest value 6 here. Okay, so that it will become n is greater than or equal to, so 9 minus 2 means it will become 11 here, and n is less than or equal to 15 will take here. So 9 plus 6 will become 15 here. So it is 11 is less than or equal to n is less than or equal to the 15. So let us plot the waveforms here. The waveform will be appearing like this. Okay, so the waveform will be appearing like this. So this is the value h of k. So from 2, 3, 4, 5 and 6th value it will be there. So this is k. This is the value 1 and this one x of n minus k. So I can move this n minus 9 anywhere between the 2 to the 6 here. So I'm going to move somewhere here at 4, 5, 6. So there are 10 samples are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is k. This is the nth sample and this is the n minus 9th sample. The corresponding amplitude is 1. This is the corresponding amplitude is 1. So this is somewhere 6 here. Okay, this is 4 here. So when you take the product of this one, so drawing the waveforms is very important here. Writing the time interval is very important. If you write this one, okay, so this is n minus 9, you can see, right? And this is the 6th position, and this is the value like this will be there. So when you take the product, so writing this waveform is very, very important here. Okay, so when we take the product of these two, the product is going to encounter from n minus 9 up to the 6, it is going to encounter here. So n minus 9 up to the 6 here. So n minus 9 can move between anywhere between the 2 to the 6 here. So this is the product of h of k into x of n minus k. Okay, so the value of y of n is summation k can take the value from n minus 9 is the upper limit and 6 is the n minus 9 is the lower limit and 6 is the upper limit 1 here 1. So this will become, so 6 plus 1 minus n plus 9 you will get here. So this is this minus this one will get here. So this plus 1 minus this one, already we know the formula. So it has become, so 6 plus 1 is 7, 7 plus 9 is, it will become 16 here, 16 correct, right? Yeah, 16 minus n will get here. So this is y of n. So this is for the case, this is for the case 11 is less than or equal to n is less than or equal to the 15 here. Less than or equal to the 15. Then let us summarize the values. We can do the summary of the values here. Next, for n is n minus 9 is greater than 6. There is no overlapping here. The value will be equal to 0 here. So if you want, you can take. So case 5, when n minus 9 is greater than 6 here, that is n is greater than 15. No overlapping. No overlapping. Therefore, y of n is equal to the 0 here. That is for n is greater than 15.